Hello everyone, I am Sanya Irfan. Welcome to Module 9 of the Machine Learning series. Today we are learning about ML pipelines and MLOps basics, which helps take machine learning from a simple projects to real production system. What is an ML pipeline? An ML pipeline is a sequence of steps that takes a data from raw form all the way to a trained, deployed model. It automates the workflow and ensures the process is consistent every time. Why ML pipelines matters? ML pipelines are important because they reduce repeated manual work, avoid human errors, make make experiment reproducible, and help scale machine learning production. Without pipelines, ML becomes messy and inconsistent. ML pipeline stages. Typical pipeline stages include data ingestion, data preprocessing, model training, evaluation, deployment, and monitoring. These stages create a complete end-to-end ML system. Data ingestion. Data ingestion is the process of collecting data from various sources such as database, files, APIs, streaming platform. This is the first step in ML pipelines. Data processing pipelines. Data pre-processing includes the cleaning, encoding, scaling, and feature engineering. We often automate these steps using scikit-learn pipelines. This ensures the same transformations are applied consistently during training and testing. Model training pipelines. A training pipelines automates the model training process. It can train multiple models, compare their performance, select the best one, save the trained model. This makes experimentation faster and more organized. Model serialization. After training a model, we save it so that it can be used later. Common formats are Pickle, Joblib, ONNX. Serialized models can be loaded into APIs, applications, or cloud services. Deployment basics. Deployments means making the model available for real-world use. We deploy models as APIs using frameworks like FastAPIs or Flask. Clients send data to the API and the model returns predictions. What is MLOps? ML is like the DevOps but for machine learning. It brings automation, monitoring, and reliability to ML system. It ensures models stay accurate and consistent over time. Why MLOps? MLOps is important because model degrade, data changes, users behavior changes, and model performance drop. So we need continuous monitoring, alerting, and sometimes automatic retraining. Key components of MLOps. Important part of MLOps include version control using Git, experiment tracking, CI/CD pipelines, monitorings, and alerts. This helps manage ML systems like professional software projects. Tools for MLOps. Some popular tools are MLflow for experiment tracking, DVC for data versioning, Kubeflow and Airflow for pipelines, Weight and Biases for monitoring and visualization. These tools automate the ML lifecycle. Monitoring models. Once deployed, models must be monitored for accuracy drift, latency issues, sudden changes in input patterns. Monitoring is important to maintain model performance. Continuous training. In continuous training, new data is collected and the model returns automatically. This helps keep the model fresh and updated without manual intervention. So, in next module, we will learn ML deployment basics, where we will understand how to deploy models as APIs and use them in the application. See you in module 10.